An engineer claims to have built an engine that takes in 95 kilojoules and expels 40 kilojoules. A. How much work can be done by the engine? B. What's the efficiency? C. Is this efficiency possible? And D. Compare the calculated efficiency to the proposed engine with the measured efficiencies in the table below. Is this value for the proposed engine's efficiency probable? Okay, so let's look at part A first. Part A asks how much work can be done. Okay, well, it's a machine, okay, and therefore it is cyclic, which means that the change in internal energy is 0. Okay, so we know that, and from there we can go ahead and use the first law of thermodynamics, which says that the heat taken in minus the heat that's removed is equal to the work plus the change in internal energy. Well, the change in internal energy is 0, so that term drops out. We can substitute in. The heat taken in is 95 kilojoules. The heat that is removed is 40 kilojoules. And so that is equal to the amount of work done. Do a little subtraction. We get 55 kilojoules. So part A is finished. Then we look at part B. Part B asks, what is the efficiency of the engine? Well, efficiency is equal to the amount of work that's done divided by the amount of heat that's taken in. So we can substitute our values in. So we have an efficiency is equal to 55 kilojoules divided by the amount of heat that was put in, which was 95 kilojoules. We can simply, now right here you might notice, okay, usually we use joules for everything and these are kilojoules. Well, since they're the same unit, it doesn't really matter what they are when we're finding efficiency because they're going to cancel out anyways. As long as they're the same, we're okay. So we go ahead and divide here and we get 0.579. Typically when we talk about efficiencies, we want that in a percentage. So we're going to change that to a percentage. So the efficiency is equal to 57.9%. Okay, so we've got an efficiency now. Part C asks us, is this efficiency possible? Okay, well, we've got these different types of efficiencies over here. We've got the calculated maximum efficiencies. And these are not taken as data, but they're the calculated maximum efficiencies, and they don't include friction, okay? So this is before friction. Well, we got an efficiency of 57.9%. Okay, well, that could possibly be a gasoline engine or a diesel engine. It's not going to be a steam engine. It's just too big, okay? But yeah, so it's possible, okay? Then we have part D. And part D asks us, compare the calculated efficiency for the proposed engine with the measured efficiencies. We're going to compare with these ones in the table below. Is this value for the proposed engine's efficiency probable? Okay, so now this takes into account friction. These are some measured efficiencies by some actual engines. Okay, so 57.9%, way too big of a jump. Gasoline is only at 25. This is double that, more than double that. Okay, so that's too big of a jump as well. And diesel, way too big of a jump. Okay, so I would say no, it's not probable. Okay, if the engineer is talking about the calculated maximum, then that's fine. But if he's saying that's what the measured efficiency is, then that's not very likely.